Today that we are going to be see here this is a Hamming window. So this is an assignment question that have been last session that you have been posted. You can see there is a question which is presented here. It is an ideal high pass filter. So which is shown here. This is an ideal high pass filter. The frequency response which is given. The range is going to be pi by 4 to pi. So that is the range of your high pass filter. Using Hamming window that your n is going to be 11, which is going to be that number of order of your filter is n is going to be 11. And the another thing that is introduced here is plot the magnitude response. There is the new things that today we are going to be discussed here. Plot that magnitude response. So this is extra things that which have been added from your assignment questions. So straight away we will solve the solution. So first step is going to be we are going to be decide that frequency response. So for this we are going to be draw the flow diagram of your frequency response with the help of your given frequency range. So that is your frequency range is plus pi by 4 to plus pi. Your range is going to be 1. That is your amplitude is going to be 1. So that is plus pi by 4 to up to pi. Your amplitude is going to be 1. So that time we are getting that pass band. And the remaining thing we are getting an stop band frequency. Okay. Then the mirror image of this right side of your graph which is going to be presented in the left hand side, that is the mirror image. So that we are getting minus pi by 4 to minus pi, we are getting an amplitude, that is pass band frequency, and the remaining things we are getting an stop band frequency. So this is our step 1. And then what we are going to be doing in the step 1 itself. So next we are going to be followed to determine that alpha. What is the formula to determine an alpha? N minus 1 divided by 2. So n minus 1 divided by 2. What is our n? N is going to be 11. So that is our given n. N is going to be 11. So 11 minus 2, which is going to be alpha value, is 5. So this is an alpha value. That is the center value. So, okay, that is the center value. That is alpha is equal to 5. Then the second step is type of filters. What type of filter? This is high pass filter. According to seeing that in a diagram itself, we can tell that that is an high pass filter, or otherwise they will be given in that question itself high pass filter. So for this high pass filter, whether we can solve that using that equation, we can able to be determine that HDFN, or otherwise we can refer the tabular column to determine that formulas. So for a high pass filter, you can see in that second row, it is an high pass filter. The formula which is presented here is hd of n, which is equal to 1 minus omega c by pi. So what is our omega c? Omega c is our frequency range. 1 minus omega c by pi, which is for the condition is n is equal to alpha. So that is one type of formula. And the second formula which is here is 1 by pi into n minus alpha sine n minus alpha into pi minus sine n minus alpha into omega c, which is the formula for n is not equal to alpha. So now we are going to be take these two formula and then we are going to be substitute here. So according to that, n is not equal to formula alpha and n is equal to alpha. So that is a two formula which is presented. So the first formula is n is equal to alpha. That is the condition. For this condition, the formula is hd of n is equal to 1 minus omega c by pi. What is our second condition? N is not equal to alpha. So that is the formula which is here. hd of n which is equal to 1 by pi into n minus alpha sine n minus alpha into pi minus sine n minus alpha into omega c. This omega c which is going to be in your frequency range, that is pi by 4. So this is the formula for n is not equal to alpha. So these two formula which have been taken from this tabular column. Simply we are taking this two formula for an high pass filter from that tabular column. Then now we are substituting that omega c value and alpha value in this n. So that is your n value is 5 because alpha value is 5 means n is equal to alpha. So alpha is 5. So n is equal to 5. N is also 5. So for this kind of things, we are substituting 1 minus pi by 4. So what is our pi by 4? This is omega c. Omega c is pi by 4, that is in the given range. Then we are getting HD of 5, which is going to be 0.75. So that is for an HD of 5 when n is equal to 5. Then next condition is when n equal to 0. So if it is n equal to 0 means we are going to be follow this formula. So HD of 0, instead of n we are substituting 0. HD of 0, which is equal to 1 by pi into 0 minus alpha. Alpha value is 5. Sine 0 minus alpha. So alpha is 5 into pi sine 0 minus 5 into omega c. What is our omega c? Pi by 4. So this condition for n is not equal to alpha. So first we are substituting 0. Okay. So we are getting that HD of 0, which is equal to 0.045. Okay. Then we are going to be substitute 1. So that HD of 1, which is equal to 1 by pi into 1 minus alpha. Alpha value is 5. Similarly, sine 1 minus alpha into pi minus sine 1 minus alpha into pi by 4. So that we are getting HD of 1 is 0. So similarly, we are expanding our n value up to the range of limits. So 2, if you are substituting 2, we are getting HD of 2 is minus 0.075. If you are substituting 3, we are getting HD of 3 value is minus 0.159. Fine. Then we are substituting HD of 4. So our value is minus 0.225. So obviously we will tell that your HD of 4 will be the mirror image of your next reflection value. So that is, for example, if I am plotting that range here means our n value is 11. Okay, is it right? Our n value is 11. So for this 11, so your n, small n, which is going to be vary from the limits of 0 to less than or equal to n minus 1. Okay, so this is the range which is going to be vary. So according to this condition, your n is going to be vary from 0 to less than or equal to, what is our n? 11. Okay, our n is going to be an 11. Our n is going to be an 11. So 11 minus 1 is 10. So for this condition, if I am expanding this limits means how we going 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, so this is the range, and 0 to 10. So how many sequence which is presented? 11 sequence which is presented. Which one is center? So the 5 which is going to be center, because this is the value of alpha. Is it right? So this is the value of alpha. So alpha is equal to 5. So this is the center of your sequence. That is why you have been find during that formula itself. So far we have substitute n equal to 0, 1, 2, 3, 4. So if you are substituting 4, what the value you are getting? Minus 0.225. If you are substituting 3, the value is minus 0.159. So far we have substituted all these values 0, 1, 2, 3, 4, 5. Then no need to substitute HD of 6, HD of 7, HD of 8, HD of 9, HD of 10. So simply we can tell that your HD of 4 value will be equal to HD of 6. Okay, so HD of 4 value will be equal to HD of 6. Similarly, HD of 3 value will be equal to HD of 7. So like that, HD of 0 value will be equal to HD of 10. So that is mirror image. So your mirror image that we can able to be tell that. So here, according to this condition, so we are going to be changes here is a HD of 4. So the HD of 4 which is going to be shown here as HD of 6. Okay, then 7. So this is the 3 value will be equal to 7, and then 2 value will be equal to 8, and then 1 value will be equal to 9. Or otherwise, in a shortest manner, how we can able to remember means just substitute the n value from 0 to 5 up to the center value. 0, 1, 2, 3, 4. Is it right? 1, 2, 3, 4. So the 5 is already substituted. Then go reverse. 6, 7, 8, 9. and then so this value will be equal to 10. Okay, so like that we have to go in this reverse order. So like that also we can able to be uh, just we can able to be remember according to that sequence values. So now we have been finished of your HD of n, which have been solved here. So far the second step is which is going to be determine that Hamming window. So according to this Hamming window, now we are going to be refer our tabular column. So only this second step which is going to be very for all kind of windows. Okay, so if you are going to be see that a Hamming window techniques here is, so you can see here the formula which is presented for two conditions. That is, the first condition is minus of n minus 1 divided by 2 to plus n minus 1 divided by 2. If you are using this condition, you have to use this formula. In this formula, you have to use plus 0.54 plus 0.46 cos 2 pi n divided by n minus 1. Suppose if you are using this condition 0, which is going to be n is going to be vary from 0 to n minus 1. So now we are using this condition, so that is n is equal to 0 to n minus 1. So we are going to be use this formula 0.54 minus 0.46 into cos 2 pi n divided by n minus 1. So this formula that we are going to be use here, so straight away we can write it that is omega hm, that is Hamming window, omega hm of n, which is equal to 0.54 minus 0.46 2 pi n divided by n minus 1. Okay, so that is that formula which we have been to use here. So according to this formula, we know that n value which is going to be 11. So by substituting n value 11 in this above formula, we are going to be get the value is 0.54 minus 0.46 into cos pi n divided by 5. Okay, cos pi n divided by 5, that is 11 minus 1 is 10. So 2 by 5, which is going to be represent is cancelled 5. So this is the range which is going to be vary from 0 to 10. So again what we are going to be do, so we are going to be substitute this n value which is going to be vary from 0 to 10. So for this we are going to be solve that values. So first we are going to be do substitute n equal to 0. So WHM of 0, which is equal to 0.54 minus 0.46 into cos 0. So if you are substituting n value 0 means you are getting cos 0. So totally we are getting the value is 0.08. Then go for the second value, n is equal to 1. So you are getting a value is 1.678. Then the third value, n is equal to 2. Then the fourth value, n is equal to 3. Then the fifth value, n is equal to 4. You are getting the value 0.9121. Then the sixth value, n is equal to 5. So this is going to be the center. So n is equal to 5. So omega hm is equal to 5. You are getting 1. Then what we can tell? So no need to substitute n equal to 6. Simply what we can tell, your 4 value will be equal to 6. So that is omega hm of 4 will be equal to 6. And then this is 7, 8, 9, 10. So that omega hm of 0 value will be equal to omega hm of your 10. So that is 0 value will be equal to 10. So like that we can able to be tell according to this Windows techniques. That is the mirror image of your graphical things. So far the second step have been completed right now. Then the third step which is going to be here is we have to determine that filter coefficient. So we know that formula for a filter coefficient is HD of n into omega hm of n. So that is HD of n, which is equal to omega hm of n. So already we have been determined for a range of your n values from 0 to 10. We have been determined HD of n. This is the first step of your filter coefficient, and this is the second step of your filter coefficients. Okay, so far now we are going to be substitute here, that is for 0, h of 0 which is equal to hd of 0 into omega hm of 0. So what is the value of hd of 0? Just we can remember that hd of 0 value is 0.045. So hd of 0 value is 0.045. Then what is the value of your omega hm of 0? So omega hm of 0 value is 0.08. Okay, so now we are going to be substitute both the value here 0.05 into 0.08. So we are getting the value is 0.0036. Then where is the n value? N is equal to 1. Now h of 1, which is equal to hd of 1 into omega hm of 1. Again we can refer that previous calculation. What is the value of hd of 1 and what is the value of omega hm of 1? So what is that value of omega hm of 1? We are getting 0.1678. So just we are substituting here those values, we are getting the value is 0 because your hd of 1 is 0. Like that we are going to be vary the n value from 0 to 10. So that is 1, 2 and then 3, and then if you are substituting 4, we are getting the value is 0 minus 0.2052. Then the center h of 5, which is the value we are getting is 0.75. Then what we can tell? So h of 4 value will be equal to h of 6. Then h of 3 value will be equal to h of 7. And then this value will be equal to 8 and then 9 and 10. So simply we can go like this 0, 1, 2, 3, 4, 5. We reach the center. Then go back 6, 7, 8, 9 and 10. So like that we are moving here. So the third step have been completed right now. Then we are going to be move forward. The next step, that is we are finding that transfer functions. So the transfer function is to determine the transfer function, the formula which is going to be a summation n equal to 0 to n minus 1, that is h of n into z power minus n. So that is that a formula to determine a transfer function. So for this transfer function, if you are going to be substitute the n value is 11, we are getting that n is equal to 0 to 10 h of n into z power minus n. So now we are expanding the limits value here. So there is an expression we are expanding here, that is h of 0 into z power 0 plus h of 1 into z power minus 1, like that up to 10 we are expanding the formula. We are expanding that formula. Then what we are going to be do? So we are referring the value of h of 0. What is the value of h of 1? And what is the value of h of 2? What is the value of h of 3? Like that we are going to be refer to the previous steps. That is your third step. So let me see here. The value of h of 0 is 0.0036. Okay. So the value of h of 0 is 0.0036. 0.0036 into z power 0 is 1. Then h of 1. What is the value of h of 1? H of 1 value is 0. Okay. Then h of 1 value is 0. Then h of 2 value. H of 2 value is, we are getting the h of 2 value is minus 0.0298. If you are substituting here, minus 0.0298 into z power minus 2. So like this, so far we are substituting the values of up to 0 to 10. We can refer here h of 10. What is the value of h of 10? H of 10 value will be the value of 0.036. So this is the value h of 10. So we are getting 0.036 into z power minus 10. So that is going to be a step 4. So that is a transfer function of h of s. Okay. Then what we are going to be see here, next step is going to be n, so that we are going to be find that the value is magnitude of h of omega. So that is the we are going to be determine here the magnitude values. So to determine that magnitude value, we know the formula, which is going to be that h of n minus 1 divided by 2 plus summation of n into 1 into n minus 1 divided by 2 into 2 into h n minus 1 divided by 2 into minus of n into cos omega n. So this is the formula that we know that to determine that magnitude of h of omega. So here substitute the value of n. What is that n value? 11. If you are substituting the value of 11, we are getting the simplified expression. So now we are expanding this limits value from 1 to 5. So that is, suppose if you are substituting 1 here, what you are going to be get? 5 minus 1. So you are going to be get 4, h of 4, 2 into h of 4. Then up to the 5 value we are going to be expanding here. So we are getting the values which is presented by according to that expression of your h of 5. We can remember where you are getting this values h of 5. Just simply we are getting the value from here 0.75. Okay, so like that we are expanding here. Okay, so this is that magnitude of your h of omega. So far this is the steps that we have been discussed in that last classes. So today that we are going to be see about that step 6. So the step 6 is we are going to be plot that magnitude plots of your given say response, frequency response. So for this, first of all, we are going to be find that magnitude response. How we can able to be find the magnitude response means just simply we have to be take a range of your omega values. Okay, so we are going to be take the omega range from 0 to pi. Okay, we know that the length of the frequency is 0 to pi, so that is 0 to 360. We are going to be change that omega value in intermittent value of 15. So there is the range value is 15, 0 plus 15 is 15 degree, then 30 degree, 45 degree, 60 degree, 75 degree, like this 0 to 180 degree that we are going to be take that range. So in the between the range limit is 15. So 15 நம்ம பிரிச்சு இந்த மாதிரி 0 to 180 வரைக்கும் நம்ம எடுத்துக்கிறோம். So now what we are going to be do here, so we are going to be determine that h of omega value that we are going to be determine here. So now we are going to be substitute this 0 value in that previous expression. So that is, we can assume that, sorry, so we can assume that this is the 5th step. In this 5th step, what we are going to be do here, we are going to be substitute 0 in this omega value. Okay, just assume that substitute a 0 in this omega value. By using the calculator, we can able to be determine the value of this 0.75 minus cos 0. What is your cos 0 value? Your cos 0 value is 1, I think so far. Is it right? Okay, then so you are expanding this. So what the value that you are going to be get here means when substituting omega is 0 substitute பண்ணனா நமக்கு என்ன கிடைக்கும் அப்படினா, so we are going to be get 0.07. If you are using calculator, you can able to determine these values. Substitute to omega equal to 0. Okay, you are getting the value is 0.07. If you are substituting 0, then substitute the omega value is 15. Okay, இப்போ எங்கெல்லாம் omega இருக்கோ அங்கெல்லாம் என்ன செய்றோம்? 15 substitute பண்ணுங்க. So cos 15. So cos 215, 2 into 15. Then cos 3 into 15. Then cos 5 into 15. இந்த மாதிரி substitute பண்ணனா உங்களுக்கு என்ன கிடைக்கும் அப்படினா, the value is 0.125. So that is the value you will be get. Okay, so far we are going to be expanding this limits value from 0 to 180. Okay, 0 ல இருந்து 180 வரைக்கும் நம்ம என்ன பண்ண போறோம்? expand பண்ண போறோம். 15 15 range வந்து பிரிச்சு expand பண்ண போறோம். 0 15, அதுக்கு அப்புறம் 30, அப்புறம் 45, அப்புறம் 60, அப்புறம் 75. இந்த மாதிரி 15 15 range பிரிச்சு ஒவ்வொருத்துலயுமே இத substitute பண்ணி we are going to be expanding this values. So then we are substituting those values.
Sir, நம்ம விருப்பம் தான சார் அது?
ஆமாப்பா, 0 to 180 நம்ம போடணும். 15 எடுத்துக்கலாம், நீ 30 எடுத்துக்கலாம். 15 ஏன் எடுக்கிறோம் அப்படின்னா பாயிண்ட்ஸ் நிறைய கிடைக்கும், பிளாட் பண்றதுக்கு ஈஸியா இருக்கும் நமக்கு. ஃப்ரீக்வன்சி ரேஞ்ச் கரெக்டா நம்ம கண்டுபிடிக்கும். அதனால நம்ம வந்து 15 ரேஞ்ச் நம்ம எடுத்துக்கிறோம். ரொம்ப கம்மியா எடுத்தோம்னா பிளாட் பண்றதுக்கு கொஞ்சம் கிராஃப் சிக்ஸாக்கா வரும், அதை அவாய்ட் பண்றதுக்கு நம்ம யூஸ் பண்ணிக்கலாம். சரியா? ஓகே, so like that we are substituting the values which are getting that omega value, h of omega value. So far that we are getting that. Then what is the next we are going to be find here? The magnitude of decibel value that we are going to be find. So for this, in decibel we are going to be find the value. So this is the value of omega in frequency that we are getting. Then now we are going to be find in decibel. How to find in decibel means just simply we have to substitute in that formula. So what is that formula means 20. So I can use here. So that is 20. Okay, 20 log. Okay, 20 log. Substitute the value of 0.07. 20 log 0.07. So if anyone having the calculator, you can find the value 20 log 0.07. So what we are going to be get? We are going to be get minus 23.1. Okay, so now we can substitute the value here, minus 23.1. Similarly, we can find here for 20 log 0.497. Okay, 0.497. Okay, suppose if you are substituting 20 into log 0.497 means so far here, yeah,
degree mode le pota pon.
For this you can use the calculator here. For determine the decibel you can use in radian mode, and then to determine here h of mode you can use the calculator in degree mode. இங்க radian modeல நீங்க யூஸ் பண்ணிக்கலாம். Okay, here you can use degree mode. So இங்க என்ன வருது -6. Someone has been told that -6.07.
07.
Okay.
07.
Okay, thank you. So like that we have to be determine here the values. So minus 23.1. Similarly we are getting minus 6.07. So far we are finding that all the omega values. So இந்த மாதிரி எல்லாத்துக்கும் நாம 20 log ன்னு போட்டு டெசிபல்ல நம்ம கண்டுபிடிச்சிக்கிறோம். சரியா? Next we are going to be plot this values in that graphical sheet. So that is the representation which is shown here. In that x-axis we are taking the range from 0 to pi, that is 0 to 180 degree. Okay, so 0 to 180 degree நம்ம எடுத்துக்கிறோம் angle values. சரியா? இங்க decibel எடுத்துக்கிறோம். The range of your decibel, we can see here that the range of your decibel, what is the range of your decibel? We can see here minusல எங்க வருது அதிகமா 23.1. So this is the highest range. Is it right? Minus 23.1. What is the lowest range? Minus plus. So plus. What is the plus value? 0.09. So that is that highest range that we are getting. So like that we are taking the plot here from 0 to minus 25. So this is also our limitations. We can able to be change 5 நம்ம எடுத்துக்கலாம், இல்ல 10 எடுத்துக்கலாம் ஸ்கேல் டெசிபல்ல நம்ம எடுத்துக்கிறோம். ஸோ இப்போ நம்ம ஈக்குவேஷனுக்கு ஏற்ற மாதிரி நம்ம எக்ஸ்பிரஷனுக்கு ஏற்ற மாதிரி பிளாட் பண்ண போகிறோம். அதாவது 0. ஸோ ஃபார் திஸ் 0, வாட் இஸ் த ரேஞ்ச்? minus 23.1. Then, so for 45, so what is the range? minus 6.07. ரெண்டுமே இங்கே பிளாட் பண்ணலாமா? So for an 0, minus 23. So this is the range of minus 23. Then we can going to be divide this. So இது என்ன வரும்? 90 வருமா? 0 to 180 னா இது 90. அப்போ இதில் பார்த்தீங்கன்னா நமக்கு, so this is 45. Okay, 45 degree. So இந்த 45 degreeக்கு நமக்கு என்ன கிடைச்சது? Value is, so just simply we can tell that the value is minus 6.07. So like that we are going to be plot the up to 180. What you are going to be get? Nearest value is 0.093. So 180 ல பார்த்தனா nearest value இந்த 0க்கு 0.93. So அந்த மாதிரி நாம இந்த ரெண்டுத்துக்கான கிராஃப் வேல்யூ எடுத்து நம்ம plot பண்ண போறோம். ஒமேகாக்கும் டெசிபல் வேல்யூக்கும் தான் நம்ம கிராஃப் வந்து plot பண்ணணும். So that is the question. If they ask plot the magnitude means you have to solve this 6th step, or otherwise we can finish it off up to the 4th step or 5th step. It is enough to determine that Windows techniques. Okay, So this is going to be that a part of your Windows techniques. So this is a procedure to plot that magnitude response. Okay. So today that we have been discussed about that hamming Windows techniques. Okay. Thank you. So